Okay, guys, we are on chapter 9, chemical bonds. All right, so the core concept, electron structure, will explain how and why atoms join together and in certain numbers. Okay, so for instance, and we've got some definitions here. So, like, the atom is the smallest elemental unit. The molecule is the smallest particle. So, for instance, like here we've got an atom of helium, but it's also considered a monatomic molecule, meaning that you can have just one atom of helium and it will still be considered a molecule because it completely fills the outer electrons. If you look at, say, these two oxygens that are bonded together, these two hydrogens that are bonded together, they are bonded together so that they can have this completely filled outer shell. And by sharing electrons, they can achieve that. So we get into that a little bit more, but I just want to show that these are considered to be molecules. They are broken down to the smallest thing that they are and still retain those chemical properties. Okay, so chemical reaction. So you have a formation and or breaking. So you either join or you break the chemical bonds in order to form new products and reactants. And so that's sort of like the definition of chemical reaction. And then you've got chemical energy, which is the internal bonding of potential energy. Hopefully, potential energy is a familiar term. Chemical equations, that's sort of like H2O. That's going to tell you, really not necessarily. This is more of like a chemical formula, but in chemical equations, you're going to have chemical formulas that you're adding together to make other chemical formulas. So, like for instance, we've got H2O plus CO2 plus basically some light is basically going to end up making, this is sort of your photosynthesis reaction. I don't know if any of you have had biology yet, but this is basically how our plants, grow. They require water. They require some carbon dioxide. They require light. And then basically they're good. They can grow. And then they also put off oxygen. You know how you always say that trees let off oxygen so that we can breathe. So then it shows another one with plant material like wood and oxygen. And that's going to yield, you're going to have some water, either as vapor, most likely, or you could even have, liquid or mostly just liquid and vapor. And then it's got some energy and also some carbon dioxide that it's going to let off. All right, so this is what I was talking about. And I want you to look at this term up here, valence electrons and ions. Valence electrons are outer electrons. Okay, so this kind of goes back to the periodic table. And if you look at the group number that those atoms are in, that kind of tells you how many valence or outer electrons that there are. And basically what's happening is that they're trying to obtain this octet rule, meaning that they're trying to attempt or to acquire an outer shell of 8 electrons. And electrons can either be gained or lost. And when that happens, you end up with an ion. Okay, so when you gain or lose electrons, you end up with ions. So, for instance, if you look at sodium on the periodic table, you would see that it has its number 11 on the periodic table. So that means that it has 11 protons. And it also, at the bottom number, it has a mass number of about 23. So that should tell you that if you take 23 minus 11, then you get this 12. That's the neutrons. That's the amount of neutrons that you get. So hopefully, based on chapter 8, you kind of are starting to realize that. Also, I put an extra credit opportunity on the content for this week, and it has you fill out some tables, and it asks you things like that. It asks you to do like the atomic number and the amount of protons, amount of electrons, and so on. And so if you look for the first shell, this kind of gets into that electron configuration. So the first shell has 2. That's this number right here. So that number right there. And then the second shell has up to 8. So that's this number 2 right here. That's the second shell. And if you add 2 plus 6, then you get 8. And then this third shell here has 1 outer electron. And if you look and see what column or group that sodium's in on the periodic table, hopefully all of you still have your periodic table, and it would probably be good to be looking at it, during this PowerPoint. You would see that it is in group 1 or column 1. Sodium's in group 1 or column 1. So what's going to end up happening is it does not like to have this 1 outer electron at all. It wants to have 8 outer electrons. It wants to obtain this octet rule right here. So what it's going to do is it's going to end up losing this electron. It's going to lose it. And it's going to give it or share it, or mostly what's going to happen is it's going to form an ionic bond with something else, which we'll get into here in a little while. But whenever it loses that electron, then it still has 11 protons. You can't ever take away a proton and it still be the same element. We talked about that in chapter 8. But now, if you add up how many electrons there are, now there's only 10 electrons. So that means you have 11 protons and 10 electrons, which means that you have an overall charge of plus 1. That would be like taking 11 minus 10. You have plus 1. So the ion for sodium is plus 1. And they write it like this. They just write a plus at the top. Now, that's only if it's plus 1. If it was plus 2, then they would write plus 2. They'd actually write the number. Now, if you look at neon on the periodic table, that's this one right here, it's number 10 on the periodic table. So it has 10 protons. Well, if you go through and do the electron configuration, it ends up to have how many total outer electrons. So don't do total electrons, because the total electrons, you would add up all of these numbers, 2 plus 2 plus 6, right? So you'd end up with 10 electrons, which that's how many total electrons it has for sure. But if you were going to add up just the outer electrons, well, let me erase this really quick. Okay, if you were going to have just the outer electrons, that's in this number 2. Okay, so if you add up 2 plus 6 here, then it adds up to 8. Well, it already had it is obtaining the octet rule, which if you look, everything on that far right column where you start with helium and then neon, those are your noble gases. And they're sort of special. They're sort of like what every other element is trying to be like. They're kind of like the cool kids because they're already fulfilled. Their outer electrons are already fulfilled. And so they almost never react with anything else besides just themselves. They just are hanging out by themselves most of the time. Okay, so I'm going to stop the video here and start a new one for this